Okay, all right. I gotta tell you. So, a grizzled old veteran of 18 years teaching like I am, I gotta tell you, I can't wait to go over this lesson. Okay, because I just figured something out. So, okay, all right. Let's see what we're doing. Okay, all right. Before I start, I gotta tell you, I was, I've been spending the last few days trying to figure out what's the best way to teach this particular lesson, and about 10 minutes ago, I finally figured it out, and I can't tell you just how excited I am, and from a grizzled old veteran such as myself, who's been around, long enough now, that I could still get very like excited over a lesson. All right. Now that also goes to you because a lot of you think as soon as you're done with school you don't have to learn again, and that's really not true. You know, real learners are gonna have to learn new things for the rest of their lives. Okay, and listen, there's nothing wrong with feeling good about yourself when you learn something brand new. You know what I'm saying? So keep that in mind, okay? Look at me as an example, all right? Not the best example, but an example. Now, what are we doing today? So today I want to, what's the best way to say it? Today I want to introduce to you something called a vertex form. Now, I'm going to give you some, I don't know, some relative historical information, all right? And this is not a history lesson. This is just a history lesson of our class. Think about this, right? When we're doing linear function, there are a couple of ways to look at this, right? So we got the y equals to mx plus b. So I'm kind of, rewinding like 6 months ago, right? When we're doing linear equations, right? We're doing y equals slope, right? Mx plus b, the y-intercept, whatnot. Now, there's a standard form. Remember that, right? So the standard form was this, ax plus by equals c, right? So today, what I want to show you is that with quadratic equations, so for example, if we have something like this equation right here. Okay, let me make sure I'm recording, because if I'm this excited and it's not recording, I'm gonna be pretty deflated. All right, so we have this equation. The question is something like this, right? Now, by the way, before I erased it, there are certain purposes and advantages of using slope-intercept form, right? And there are certain advantages and purposes of using standard form. So just as it's useful to look at a quadratic function in this particular manner, right, the way that we've been operating with, there is another form, right? And I'm gonna show you exactly what the purpose is, all right? Now, I think I should just tell you right now, because the topic of this lesson is called vertex form. So in other words, there's a different way of writing an equation, just so that, hold on, I need some water. God, the school is so dry, insane. All right, okay. Now, what was I saying? Yeah, so there's another form, but I want to show it to you instead of just telling you, okay? So now, first of all, based on this equation, this is the graph for it. This is the parabola for it. Okay, I need some more water. Hold on. So, and in case you don't believe me, this is the graph, all right? I reproduced it, all right, on the graphing calculator. So this graph, hold on, the light just went off. I can't believe this. All right, so this is the graph, right? And so now, since this is called the vertex form, we're gonna focus on the vertex for a second. All right, which is down here. Now, what's the coordinate of this vertex? Take a look. What is it? Yeah, it's 1, -4. Right, so keep that in mind, all right? So that's the vertex. And I'll show you the vertex form then, all right? And I'll tell you what that is, what that means. The vertex form of this particular graph is this equation right here. All right, here it says, right, in parentheses, x minus 1 to the second power minus 4 equals 0, right? Now, I want you to examine this formula very carefully. And I want you to tell me, right? Now, think about it, right? If we're looking for the vertex, and by looking at this vertex form, can you see where, in what ways we can simply just by looking at this formula, right? I'll repeat the question. Just by looking at this formula right here in the vertex form, can you tell me what the vertex is, what the clues will be? Look at it, examine it very closely. Yeah, look, right here. 1 and -4. You see that? So the purpose of a vertex form is very straightforward. It is simply written in such a manner so that you can see the vertex immediately. All right, got that? I'll say it one more time, all right, because this is really important. The vertex form of a quadratic formula, right, is written so that you can see the vertex just by looking at the equation. Now, I think that's pretty cool, all right, first of all. And second, some of you might look at this equation and say, yeah, but Mr. Ng, it looks so different. How can these two possibly be the same equation? So what we're gonna do is we're gonna have a little investigation and find out. So watch this, right? So what I'm gonna do is I'm actually gonna work out this equation. Meaning I'm gonna take this, let me just rewrite this. All right, let me just make sure I'm still recording. All right, good, all right. I'm just gonna do this, I'm just gonna work this out using FOIL, right? So you see why we have to do FOIL prior to this, right? And even the harder questions, right? Now, right, first, outside, inside, last, and then -4 equals 0, okay? We don't worry about the equals 0 for now. Now, here I got x squared, negative x minus x, right? Combine like terms, right? That's -2x. 1 minus 4, that's -3. Oh, look. Where's my highlighter? Oh, look. Same thing. See that? Same exact thing, right? Particularly this right here. I messed up. That doesn't help. Okay, that's not what I tried to draw. All right, this and this, they're the exact same thing. So in other words, right, these equations are equivalent, and again, it proves that, it goes to show you that the purpose of this vertex form, the purpose of the vertex form is to really show you the coordinates of the actual vertex, okay? Which again, I think is really, really cool. Now, do me a favor, all right? And I almost never do this with you guys, all right, in a video, all right? Could you do me a favor and write this down right now, all right? And most importantly, this part. So this is the general vertex form, all right, of a quadratic function. Now, hold on 1 second. I'm gonna go check to see if this is actually on the Regents reference sheet. So give me 1 second. Okay, so it's not provided. Now, don't panic just because it's not provided on the Regents, okay? Because all you really need to know about this formula, again, is to focus on these two particular parts, all right? Hold on, let's see. Right here, the H and the K, right? See that, right? HK is the vertex of the parabola, okay? So again, right, if you should probably pause the video to copy this right now, and then afterwards I need to explain to you in some more details how to actually solve some of these questions, okay? So press pause right now. Okay, all right, and we're back. So now, I don't know if you've noticed this very tiny little detail, okay? And it's a very, very tiny detail. So what I'm gonna do is I'm gonna erase all this stuff that I wrote on the side right now. And I want to just focus on this particular equation. And I'm gonna write it out again. All right, so here we got x minus 1 squared minus 4 equals 0. right? Now, I don't know if you noticed. Here, hold on, I'm waiting for the marker. Here, right, you notice how with the vertex for the second coordinate, right, the y coordinate, it's -4, we keep it. Have you noticed that? But for some reason, for the x coordinate, we don't take the negative, right? We only take the number here. Now, there's a reason why for that, okay? So, and we're gonna get very technical here right now. Have you noticed that for this equation, oh, I shouldn't, let me use a different color. You see how this is minus h, not plus h, right? So let me show you this then. All right, I hope I do a sufficiently good job explaining this part. Now, we're just gonna focus on this, the x minus 1, right? So here's the question, all right? Big question, most important question of the day, actually. How is it possible, right, if you have x minus 1 already, and the formula says x minus h, right? So again, I'm just taking like very specific parts of this, right? Compare this, right? They both say minus, right? So that means h is 1, right? And then for this one, we kind of just keep this one, right? We got -4. However, if I show you something like this, all right, and now we're gonna shift gears, right? How would you be able to tell if the vertex, the first value of the vertex, is going to be positive or negative, right? Because now it seems a little bit arbitrary. Now, we do know that this second value is gonna be a -5, right? And that begs the question, right? If you just examine this little part here inside the parentheses, is that going to be so would that make this a 2 or -2, right? That's the big question. Here's how you can look at it. If the formula says x minus h, I mean, yeah, right? The question is this, what does x have to subtract so that you get a +2? So again, let me repeat the question. X minus what in here with the h? Here, where you will turn this into x plus 2. That's the question, right? What does this value have to be? Yeah, -2, right? Because x minus -2 means x plus 2, which means these are equivalent expressions. So that means that when this is positive here, the 2 here has to be negative, okay? Now, I hope I did a good enough job to explain that, so I'm going to do it one more time with the next question, okay? So let me use a different color then. So one more time, all right, for this one then, right? Now, again, right, to find a vertex, you can pretty much ignore this, right, and the exponents, okay? The exponent just tells you it's a quadratic equation now. So one more time, right? If the form, right, let's go back to the equation. If the general form is x minus h, in general, right, that's generic form, and I have x minus 1, what do you think h has to be? Yeah, just 1, right? I mean, just simple substitution, right? So I know that my first value is going to be +1, and this is going to be 3, okay? Now, I already know, I can imagine if I'm teaching this in class, in the classroom right now, what one of you will say is, Mr. Ng, like, don't make it so complicated. Just if you see 2, make it the opposite, right? If you see a +2, make it a -2. If you see a -1, just make it a +1, right? And you can see that that's -2, right? And this is +1, right? So why are you doing all of this? And the reason is because if I just tell you to think about the opposite every time you do this, it's just very hard to memorize because like we've learned so many new complicated concepts this year that adding one more thing for you to simply memorize is gonna be like it's just a lot of things to memorize, okay? And that's not the best way to learn, okay? So that's why I wanted to show you at least to some degree how to do that. Now, to get the real answer, okay, you're gonna have to go on YouTube here, all right, with Khan Academy. Sal Khan is gonna explain to you why the whole thing is in the first place. But I think for us right now, this is good enough, okay? Now, how are we doing on time? of course, is 1441. All right. So now, let's just finish these 4 remaining questions, okay? And all we're going to do in these questions is look for the vertex. That's it, okay? And I just want to make sure that, we get some sort of momentum before we move on. All right? Now, look at this one. Look at this third one here. What do you notice that is missing from everything we've done today, right? So again, look at everything we've done today, all right? Vertex form, vertex form, vertex form, vertex form. Uh-oh, what is this? By the way, just so you know, that's in the vertex form. Think about that. Think about how you can rewrite this. I want you to think about that for a second. How would you rewrite this in vertex form? And it's not complicated. There's really not much to do here. All right, so let me show you. How do you write this in vertex form? Well, we have h of x, right? Negative. Now, first of all, you realize that we could put the negative outside of parentheses, because it actually doesn't change anything. You realize that, right? Like, because negative times, even if I just put x squared here, these two expressions are equivalent, right? Negative x squared and negative in parentheses x squared right now is still the same, because negative times x squared, right? Whatever that is. So now, then, having said that, what number would I have to add or subtract, right? Because, the generic form is subtract. Hold on. Because the generic form is subtract, right? What do I have to subtract to keep this whole thing just like this? Yeah, 0, right? You see that, right? Because x squared and x squared minus 0 are one and the same thing. There's no difference between the two expressions. So that means the first coordinate then, maybe I should use highlighter early and often, all right? It's 0, 4. That's it. Now, if you don't believe me, you can put this in a graphing calculator, all right, like I did earlier today. Hold on, how am I doing on time? Uh-oh. It's okay. I'm gonna keep the lesson short tomorrow, okay? It's just sometimes it just takes so long to explain a concept. All right, so let's see, negative x squared plus 4. Negative x squared plus 4. Right? See that, right? 0, 4, right? Look at the vertex. 0. Oops, went too far. 0, 4. That's it. You see that, right? Okay, good. All right. Now, what about this one then? What about this one? How would you rewrite that in vertex form? Right? Again, look at this, right? We have to have x minus h squared, right? So I'll rewrite the original. How about that? Y equals to x minus h squared plus k, right? Let me double check. Yep, right? So look, x squared is already here, right? So what do you think goes in here? Yeah, again, 0, right? Notice that, right? X minus, if this were 0, doesn't change anything, right? The lights went off again, hold on. Okay, all right, so now, what's k then? What do you think? Yeah, another 0, so what's the vertex? Yeah, 0, 0. That's exactly what that is. So if you put this into your graphing calculator, you notice that the vertex is 0, 0. Okay, so far so good, all right? I think you guys are getting the hang of this. All right, even though, like, no one has answered a question in this video. All right, now, same thing, right? Let's just look at this as the example. All right, so I don't have to rewrite over and over. Same thing, right? How would I rewrite this from here to here? Yeah, right, so here's the opposite. By the way, okay, another trick that you can do, all right? If you feel like there's something you have to do when you solve these, set all of these guys to 0, meaning this, all right? So look up here. X plus 2 equals 0. Subtract 2 on both sides. X equals negative 2. Boom, right? Correct. This one. X minus 1 equals 0, plus 1 on both sides. X equals 1, right? Where is it? Boom, right here, right? Same thing, okay? Here you can set x squared, you can set x squared or x equals 0, right? 0, right? You see what I'm saying? All right, so again, let's try with this one, all right? Looking at this, if you want, you could take, I'm running out of space, all right? X plus 3 equals 0, subtract 3. What's that? Negative 3, right? Now, what's the second point? Plus k, so this is plus what? Yeah, 0, nothing, right? That's the whole point of this, all right? Try this one on your own, okay? How about this one? Try this one on your own. Press pause right now. Okay, all right, so here for this one, I can do x minus 4 equals 0, so that means x equals 4, all right? So the vertex, I'll just write the vertex. Vertex is 4, what? Yeah, negative 1. That's it, okay? So that's the lesson today. Again, hold on, how much time do I have? Oh man, it's 20 minutes already. Okay, so if you want to look further into this, this is optional on Delta Math, a deeper dive into the vertex form, okay? Because I think Sal Khan did a pretty good job of explaining, like, you know, much deeper into what I do. But sometimes, you know, when I'm doing this, especially as a video form, that I don't want to go so far into the rabbit hole that, like, that I'm gonna lose some of you, okay? So that's why I think this is a good, kind of a good medium place for me to teach from, all right? So if you don't 100% get this yet, don't worry, we're gonna practice at least again tomorrow, if not the day after, all right? Thanks for paying attention, thanks for watching this, have a good day, and I will see you later. Okay, bye-bye.
OMG, that was so good.